Hi, good afternoon. Thanks for coming out to see my talk here at Findevr. It's great to be here in front of the financial services community. Aerospike is, how many people have heard of Aerospike? Okay, not bad. So we are a NoSQL database. We've come of age in the internet age. We are a venture-backed company here in the Bay Area, founded with industry database insiders such as myself, my co-founder out of IBM Labs, folks from Sybase, and a number of other database companies. It was our goal to create a new next-generation database that was highly scalable, high availability, and focused around the needs of transaction processing. What we found is that high-performance NoSQL, a NoSQL that creates a new technology stack. So instead of using the old SQL system where you create queries, and you need an app server to do that, and then you have a second layer of processing, the SQL server, which also has to be high CPU, and then a database, then a storage layer underneath, and often a cache in front of it. Those 4 layers in the NoSQL system have been collapsed into 2. So I'm going to tell you the use cases that we've started to see within financial services and a little bit about the deployment patterns we've seen. Aerospike, since its founding, has been used primarily within advertising use cases. These are a selection of internet scale customers. You may notice AppNexus, the New York firm that does a lot of advertising and advertising platform work on the internet. These guys are all using a very similar style of technology to what I'm going to show you is happening within financial services and fraud. One of our claims to fame is if you remember one thing from my talk is if you're currently using the NoSQL pattern within a fraud system and you're using Cassandra, we can give you access to a lot more data in a lot less time. We are simply far more efficient than Cassandra. So if you're using that pattern, you've already got Cassandra working, Aerospike can show you a way to more data in less time, which will improve your fraud detection results. Just a moment about the database itself, and I'll move on to the actual use case we see with high-performance NoSQL. So we're a clustered database. That means that you can lose nodes and still maintain high availability. It's a system that is truly peer-to-peer with no special nodes. Does require an application server, and I'll go into that pattern of use. And that application server has native library support. That's very important because what we find in these fraud detection cases is that each and every application developer needs their own language. We find people who are primarily doing their algorithmic work in, say, Java with fraud detection, but then also need scripting from Python, need to move data in and out with a SQL connector, etc. So those native client libraries are a key to the kind of fraud detection use we're seeing into a cluster of high-performance NoSQL servers that are a full distributed peer-to-peer system giving high availability. So how does this actually impact fraud? Great, you have a key value system that is excellent at doing individual lookups for individual small pieces of data. In the advertising use case, what we found was decisioning was used when you had a user profile. So imagine that advertising case where you're trying to track 1 to 10 billion cookies in North America and all of the user information that comes with it. In North America right now, real-time bidding, which is the transaction system that prices each ad on the internet, is currently running at about 5 million transactions per second. 5 million. With an SLA of 10 milliseconds required including computation, leaving about 1 millisecond for the database. In those patterns, an application writer in advertising has to write math, usually a series of expected value calculations based on recent data, in an application server, often in C, often in Java, sometimes in C#. But why do you need 5 million transactions per second, which is the kind of speed that Aerospike works at, in a fraud detection system? How can Aerospike help power a high-performance, innovative fraud system? Our goal isn't to be the rules engine. Our job is to power the next generation of rules systems. The key is this diagram here. So what you see is you may only have 500 to 1,000 payment processing transactions happening in real time in every second. But you want to touch as much data as possible to make the most accurate decision possible. That's going to be very small pieces of data that are randomly distributed. It's very hard to figure out what's going to be the pattern of an individual lookup. And you want to give your algorithmic guys the best chance at creating a really interesting, innovative algorithm. Often, we are finding now that the amount of data that these next-generation fraud systems use often wants to touch between 2,000 and 5,000 individual data elements to make a new computation. That easily can push you into the range of millions of transactions per second with millisecond to 10 millisecond latency. If you have a data layer with that latency, you can provide some really interesting computational power. Now, this isn't to be confused with the analytics that you have driving this system. Of course, you're going to have a research database. You're going to have a lot of research databases. You're going to have a data lake, you're going to have Hadoop, you're going to have Spark, you're going to have even in-memory databases in that tier in analytics in order to calculate fast-moving patterns. What you also need as part of this core operational system is the ability to very quickly write data as well as read. What we found in advertising was that recent behavior is the most effective behavior. If you have a fraud pattern developing, you may need to keep recent, say, IP address traffic or purchase right on the front edge, as opposed to round-tripping it out to your analytics system and then pushing it in tomorrow, which may be too late to provide the most accurate fraud. So let's go into a little more technical detail about how this works. So what we find is that with advanced fraud scoring, instead of creating a rules engine, you typically have an application environment, let's say Java, that is trying to do something that's beyond what can be expressed in a typical rules engine. Let's say, for example, machine learning. In machine learning, you're going to have features. These are features that have been found out of your research database. And you're going to have an application layer that is running those kinds of libraries, libml, possibly within a framework like Spark, but often simply coded within your application environment. So the guys we're working with, the payment processors we're working with, of course, I can't tell you about the algorithms they're using, right? That's all secret, covered by our NDAs. So instead, let's just look at the data and computation patterns. For example, IP addresses. There are between 2 and 4 billion IPv4 addresses in the world, so you're going to need a fair number of objects. You don't just need 10 million objects or 100 million objects. You're going to need billions of objects to keep track of traffic by all IP addresses. Now, if you were doing this in SQL, what you might do is a table that looks about like this. Each individual piece of information, each fraud score for an IP address range, may be represented in a table that looks kind of like this. I have a start IP, an end IP address, an ID of an individual piece, an individual score, and then the score itself. That's how it would look in a SQL system. However, let's think for a minute about what a database is going to have to do when it executes a select statement like this. It has to look up in that index and do usually several different accesses to storage in order to do that computation. Even in a system that is a purely in-memory system, you will typically find between 5 and 10 milliseconds of delay for requests like this. Part of that is due to parsing the SQL statement, and there's ways to fix that, right? Your DBA can tell you different improvements on that. But let's face it, that's a very basic system. You might as well use a rule engine. What happens if you're trying to use individual behavioral elements as part of your fraud score? Well, it's going to look something like this. You're going to have a table. That table is going to have recent behavior by IP address and a timestamp and what the behavior is. Now your app can actually reach in and see for a given IP address what that behavior is and start to score it. You've got a lot of writes on that table and a lot of reads on that table, but think about, again, what the database is going to have to do. On every insert, it's touching that index of the IP address and the timestamp and then look up against it. That's not going to be an efficient operation when we're talking about millions of transactions per second. What does this kind of pattern, technical pattern, look like when you're talking about a NoSQL pattern. There are many NoSQL databases, not just Aerospike, but let's just start thinking and translating this from a SQL pattern to a NoSQL pattern. Well, instead of having a table with multiple entries, NoSQL allows you to put lists or documents as elements within your database and is mostly key value. Key value operations are the key to high performance and scale because they are embarrassingly parallel. You've got one server, one key that you're looking for. That client can sit there and figure out exactly which server has the data, and without any load balancers and without any extra network hop, go directly to the least loaded server and get that data. So you want to stay on the side of key value, and this is an old database trick. In some sense, there's nothing new under the sun. This is a primary key. And anyone in any database would say, you want speed? Have a primary key, index by primary key, and you'll get high performance. So in some sense, there's nothing new here. What's new is the ability to have lists and to use multiple hops at the application layer. So instead of relying on joins in database and monolithic servers, you might have to do 2 network round trips. So first, I might have a given IP address range to get my list, which might pull a set of networks, and then I would do a batch request to get recent information about each individual network address and those scores. Sure, it's 2 network round trips, but it's incredibly parallel. These are the kind of key value operations that can be satisfied in 0.1 to 0.2 milliseconds. So even with the 2 round trips, you're getting in the range of 0.5 to 0.7 milliseconds, leaving a massive amount of time for your computation and for the doing more data. If you're trying to get 5,000 operations within the 10 milliseconds, this is the kind of pattern that we find successful at doing it. Now let's go one step further, because that was just the fraud scores. Let's go to behavior. Within a behavioral system, again, you have this trick, this NoSQL system of being able to have a collection, not just a list or an element, and thus you don't have to use index table scans. When you have a new behavior, you can tack it onto the end of that collection. So your write is key value. It does a simple update operation, high performance, parallel, as well as then being able to go and fetch it with that level of performance. So this is essentially the reason you should consider if you have a high-performance fraud detection system using the NoSQL data patterns. The other benefit of moving to a NoSQL system is the ability to use libraries. There's a lot of great Java libraries out there, and the data scientists that you work with are going to be innovating. They're going to be thinking of great new algorithms that are best expressed in procedural languages with those style of interfaces. We've done some work with Datto. They used to be called, I want to say Graph Lab out of Carnegie Mellon, another NEA company like us, funded by the same VCs. We used their system to figure out machine learning for traffic prediction on California freeways. And using that, we were able to find some very interesting patterns for predictive analytics. However, Spark is another system where machine learning and ML libs, Big ML another one, that allows you to use Java, and those things don't emit SQL, right? They want to speak in NoSQL and key value and procedural systems. So again, the key to this kind of performance, this new modern scale-out architecture, instead of having a load balancer, cache, a application server, a SQL database processor, and then a storage layer, is to collapse really the compute tier and the storage tier and get higher performance. In my experience, in my 25 years in Silicon Valley, there's a beauty to an architecture when you only have 2 layers. You need a compute layer for scalable compute. As your architecture, as you're trying to get more compute in your algorithms, you want to be able to scale that. You don't know up front how many cycles you need in the future for new algorithms, and you want to be able to scale storage. Those are the 2 dimensions, and when I see a diagram like this that has the 2 independent layers and a network between them, this is an architecture that makes sense to me. So let's talk for a second about the kind of scale you can achieve with these next-generation NoSQL systems. This is the rough profile that I have seen within the fraud detection, immediate fraud detection and intervention systems within the customers we're currently talking to and deployed to. Roughly, there are 10 to 50 billion objects. There's a rough size of about 300 terabytes of data online. Remember, this is your operational store. You may have a much larger analytics store, petabytes and petabytes of data. This is the data you're keeping that is actionable, let's say all of those IP addresses, recent behaviors. About 2 million transactions. Remember, there's business transactions and database transactions, and about 50 to 100 millisecond SLA required, and of course, domain replication. One of the benefits that Aerospike can give you is if you were trying to do this with a purely RAM-based system, it would be extortionately expensive, right? You can put together 300 terabytes of RAM. There are systems that allow you to do that in a reasonable chassis size, or if you're within a cloud system, but it is a bit expensive. The price is not so much the cost of the chips. The chip providers have been doing a great job reducing the amount of chips required and the price of chips. The problem is power. Power is not getting any cheaper, and RAM is a technology that continues to require RAM as the data is used. NAND flash has made extreme strides even over the last year and a half. Previously, we had SATA systems that were fast and could be tricked into showing these kinds of performance gains and 500,000 IOPS, 500,000 transactions per server. But it often required very particular host bus adapters, RAID cards, and chassis. The fact that the flash guys have brought NVMe, which is a form of PCIe, an in-database card, into the picture, have allowed us to show things like 1 million TPS per card within an Intel system. So I'll show you what some of those build-outs look like. Now, if you're in cloud environments, I'll show you some of the numbers that have occurred with that. But these NVMe systems have a second benefit that has just recently come available on the market if you're building a data center, which is everyone hates these cards. I hate them. Any ops guy will tell you, I hate cards. They're annoying. I have to figure out the number of cards, and if I ever have to change the number of cards, God help me, because the hands in my data center will probably screw up if I have to pull a chassis. We've all gotten used to front panel, SATA, and SAS systems with rotational disk. NVMe now has a connector called U.2 that is front panel 2.5, and yet still has the performance that we see here in PCIe devices. Now, Aerospike has been working closely with device manufacturers because the problem of low SLAs has not well been tested within the industry. They typically talk about transactions per second, IOPS per second, random reads and writes. What you actually want is the kind of testing that shows what the SLA is over time. So here's a quick look at where we've come to and now where we are in terms of the amount of performance that we can now achieve. And essentially, you see down at the bottom, that's where we are now with recent NVMe drives from Samsung and Intel specifically, but there's also great drives out there from Micron. 2013, Micron really had some industry-leading drives. So now that you can easily get upwards of 150,000 transactions per second and still say at 0.2 to 0.3 millisecond, 95% latencies. So pretty amazing stuff out of Flash. Now, I hear a lot about Flash that says Flash is not reliable, NAND's not reliable, and our experience at Aerospike is simply otherwise. Within our internet community, we've had thousands of drives, hundreds of customers running. Now, you do need a distributed system and a high availability system because drives will fail, just like rotational drives. Kind of like a RAID system, you need to be able to pop in and out drives. But the reliability we've seen exceeds greatly rotational drives. So if you know how to deal with those and know how to build an operational runbook around rotational, you'll be fine with this. Examples of build-outs that are practical today are systems that include 1 million IOPS or 200,000 IOPS, that's a SATA system, and gets you up to hundreds of T within small server counts. So just to wrap up, Aerospike has the experience within this area of working with both Flash as well as in the advertising community, very fast, very cutting-edge decisioning systems. And this pattern of using NoSQL and going beyond SQL to bring in machine learning and the advanced algorithms, we hope to be a database of choice to help your company if you are doing fraud detection in an innovative way. If you're using a system like Cassandra, we want you to touch more data and spend less time building databases. So thank you very much. Oh, and by the way, my colleague here, Gino Thiers, we will be giving away this fine drone at the end of this question and answer. So if you'd like to scoot down and put your business card in the column, we'll be doing that drawing right afterwards. And you can catch us, of course, at the cocktail and beers up at our booth after this.